We are camping in the Allen Hills, which is about 90 miles north of McMurdo Station in the Transantarctic Mountains. What we're doing here in Antarctica is studying fossil plants and fossil forests in the early Jurassic about 180 million years ago. We've been camping here for about a week, and the purpose of this camp is that we have helicopters land here and pick us up, and we go and work at different localities to find plant fossils. We also work locally on foot looking at plant fossils in the surrounding stratigraphy.
This comes from Carapace Nunatak, and it's Jurassic in age. The whole setup of Carapace is basically a lot of basalt flows coming into like lake sediments and other environments. Most of it is in the mountain itself, but over time a lot of this erodes out. This material we actually found on the moraine, so you could just walk around and pick up the material on a moraine, which makes it a lot safer for us and easier to collect material. Here's a nice specimen here, and you can see various lines in here. Some are distorted, but all the plant material occurs in these dark lines.
We've, in the last week, actually increased the known diversity of plant fossils on Antarctica in the Triassic. We've uncovered some brand new fossils we don't really know much about. They're brand new to Antarctica. And we've also discovered a tremendous amount of diversity of plant life in the Triassic, just from this locality alone. So this is a very important find here. Some leaf fossils there. Some dichoridium here. Looks like a ginkgoid leaf there. So if you continue to break these layers open, you might find more complete preservation of those leaves. And what we're seeing is just little fragments of the leaves on these exteriors of these bedding planes here.
This is a piece of Triassic wood, and this one's really rare because you have the stem that's connected to the roots, and that is pretty amazing. And so this is from a fossil forest that was just found yesterday, actually, so it's really great. But to actually find a forest, which is called in situ, which means that's where it was originally when it died, is extraordinarily rare. This is one of about 37 of these in situ trees at this forest, so really incredible. And a lot of them are pretty rotten out, and that's really great for looking at the ecology, like what were they doing there, how did they die, and like how was the ecosystem back in the Mesozoic. And so really great find.
We don't really have plants that exist at polar latitudes today. If you continue the current trends of climate change, that we might see different ecosystems migrating in the northern hemisphere towards the North Pole, but we don't understand exactly how that type of plant migration will occur, which plants will move northward, and what will happen to the ecosystems at more southerly latitudes. And so the importance of these fossils in Antarctica is that it preserves that record of that plant change, that plant community change, and that plant migration. And that's all basically crystallized in the fossil record.
Our job, of course, is trying to reconstruct the plants, and as you can imagine, it's quite hard because this is pretty much like a salad or a compost heap. You know, we have to use different characters of the plants to try to put the right plants together, the right parts, a little bit of detective work.
This is essentially a career. I mean, like, you could spend your entire, like decades of work on this. So for example, in this piece, you can look at this and you can cut it up, you can describe it anatomically, morphologically, you can give it a new species name. I can look at the microbial component of this. You can give this to a geochemist. They can look at the chemistry of it, so what was present here, and then you can give it to like a sedimentary geologist. They can say, oh, this is how it was preserved, this is the type of landscape it was in. So there's an entire like multitude of questions that can just come from just a single piece, and that's really the incredible part about our job. You could just answer so many questions with this, and probably things that we haven't even thought of like today. Just keeps on building, so it never ends. That's great.